This video is for skills review number 3, talking about polynomial operations and evaluating functions. So, as a review from Algebra 1, adding and subtracting polynomials is just combining like terms. So, when I look at the example here, I'm adding together. Now remember, there are parentheses, so technically we are distributing a positive 1 in each of these. If this was negative on the inside, we'd have to distribute a negative sign. So really, when we rewrite this, we have x cubed, 1x cubed, plus 3x squared, minus 4x, minus 8, plus 2x cubed, minus 5x squared, minus 6x, plus 1. Again, if this was a negative, it would change all our signs, but it's not. So from here, we just combine like terms. So 1x cubed and 2x cubed makes 3x cubed. 3x squared and negative 5x squared gives me negative 2x squared. Negative 4x and negative 6x gives me negative 10x. And then lastly, negative 8 and positive 1 gives me negative 7. Just combining like terms. Now, when I multiply, we need to go ahead and distribute each term and multiply the coefficients and add the exponents when they have like bases. Okay? Notice up above, we did not add any of the exponents here. X cubed and 2x cubed doesn't make 3x to the 6th. When I multiply, we have to go ahead and add our exponents and simply multiply the coefficients, and then look to combine like terms if possible. So, in this first example, we used the distributive property. 2x times x gave me 2x squared. 2x times negative 6 gave me negative 12x. 5 times x gave me 5x. And lastly, 5 times negative 6 gave me negative 30. So, we would stop here. However, we look to see like terms. No other x squared terms, but negative 12x and positive 5x together makes negative 7x. Combining like terms there. On the other example, remember when I square something, if I ask you to do 3 squared, you know the answer is 9. But really what you are doing is you are doing 3 times 3, which gives us the answer of 9, multiplying by itself. So when I give you x plus 3 squared, we have to first rewrite it as x plus 3 times x plus 3. From there we go ahead and do our distributive property. X times x gives me x squared. X times 3 gives me 3x. 3 times x gives me 3x. And 3 times 3 gives me 9. Looking to combine like terms again, 3x and 3x gives me 6x. Okay, so go ahead and give those a try. Answers on the bottom. On the back, evaluating functions. Remember, evaluating a function simply means we are replacing a variable with a number or expression. So, in this example, when I say t is equal to negative 4, that means we take the t and we substitute it. We take negative 4 and substitute it everywhere we see a t in the original expression. Now remember, there's a shortcut way for writing this. G of negative 4, again, that just means t is equal to negative 4. We substitute it in. We use our PEMDAS. We use order of operations to go ahead and simplify, and we get an answer of 35. We saw this rule change slightly, and just by that, we get a little bit more evolved. When I give you a piecewise function, we have multiple rules that we could use. We need to figure out where our value, in this case h equals negative 6, goes into. Does it go into the top equation, or does it go into the bottom equation? The way we determine that is based on our domain restrictions here. The top equation is governed by values that are less than or equal to 0, and the top is governed by, or the bottom is governed by x is greater than 0, top less than or equal to 0. So if we asked where does x equal negative 6 fall, it goes into this expression, x equals negative 6 falls in this domain, so we would use 2 times x minus 3, which we see happening down here. 2 times negative 6 minus 3, giving us the answer of negative 15. So again, just figuring out which portion it goes into. And you have some problems to go ahead and try for that.